In 2026, artificial intelligence is not just changing software, it is redistributing industrial capacity. It is straining energy systems. It is reshaping semiconductor production. And it is quietly altering global logistics flows. This is not just a tech story, it is a supply chain story. Let's start with energy. AI data centers consume extraordinary amounts of electricity. Training large models requires vast computing clusters running continuously. In several countries, new data center projects are already forcing upgrades to grid infrastructure. But electricity is only one constraint. Memory is another. The global DRAM market is highly concentrated. 3 companies, Samsung, SK Hynix, and Micron, control the majority of global supply, and they have made a strategic decision: shift capacity toward HBM, high bandwidth memory, the type required for AI servers. HBM is more complex, more advanced, and significantly more profitable. But semiconductor fabrication capacity is finite. When more wafers are allocated to HBM, fewer are available for conventional DRAM, the memory used in laptops, smartphones, gaming consoles, vehicles, and industrial electronics. This is the key mechanism. AI demand does not just increase total production, it reallocates existing capacity. And when capacity is reallocated, someone else gets less. That creates price pressure. But the real disruption begins when manufacturers anticipate shortages. Electronics producers do not wait for confirmed scarcity. They react early. They front-load orders. They build inventory buffers. They secure long-term contracts. This behavior amplifies volatility through what is known as the bullwhip effect. A modest increase in end demand becomes a significant distortion upstream. Memory suppliers see demand spikes and prioritize high-margin clients. Perceived scarcity increases. Smaller buyers lose negotiating power. And then the disruption moves to logistics. Most advanced memory production is concentrated in South Korea and Taiwan. When multiple global buyers attempt to secure supply simultaneously, freight markets tighten. Air cargo space becomes scarce. Container bookings surge. Lead times extend. And when memory is a critical input, for example in automotive control systems, manufacturers cannot afford delays. A European car plant producing thousands of vehicles per day cannot stop assembly because the memory module is missing. So companies shift from ocean freight to air freight. Air transport can cost 3 to 5 times more than sea transport. That cost flows directly into the final product price. But there is a second-order effect. When electronics firms increase air freight usage, they compete for capacity with pharmaceuticals, aerospace components, and high-value industrial goods. Freight rate volatility increases across sectors. Logistics planners lose predictability. And when predictability declines, inventory costs rise. At the same time, companies attempt geographic diversification. Assembly shifts toward Vietnam, India, and Mexico to reduce concentration risk. But diversification does not eliminate dependence on upstream semiconductor production. It simply changes trade corridors. More Asia to North America flows, more pressure on specific ports, more exposure to regional bottlenecks. This is how a technological shift transforms physical trade patterns. There's also a medium-term risk. New semiconductor fabs are under construction in the United States and across Asia. If significant new capacity comes online in 2027 or 2028, and AI demand growth stabilizes, the system could swing in the opposite direction. Oversupply, rapid price corrections, sudden freight volume contraction. We have seen this cycle before in semiconductors: expansion during a scarcity, correction during normalization. Logistics markets are not immune to these cycles. They amplify them. The memory tension driven by AI is not just a temporary imbalance. It is a case study in how digital innovation reallocates physical industrial resources, energy grids, fabrication plants, air cargo capacity, shipping lanes. Artificial intelligence is not only transforming algorithms, it is reshaping the infrastructure of global trade. And for professionals in logistics, supply chain, and international commerce, the lesson is clear. When technology demand spikes, watch where industrial capacity is being reallocated, because that is where the next bottleneck will emerge. If you found this analysis useful, subscribe for deeper breakdowns of how technological and geopolitical shifts impact global trade and supply chains. In the next videos, we'll continue connecting news events with their real economic and logistical consequences.